All right, today we're diving into one of the greatest adventures humanity has ever undertaken, the Voyager Grand Tour. It's an incredible story of pure genius, breathtaking discovery, and a journey that pushed us all the way to the edge of our solar system, and then kept on going.
So, let's set the scene. The year is 1989, and the entire world, pretty much, is looking way out into the darkness of space, just waiting for the final chapter of a journey that started 12 long years before. And this magazine cover, it just perfectly captures that feeling, that global anticipation. Voyager was almost there. It was about to arrive at Neptune.
And you know who better to capture the mood than the man himself, the legendary Carl Sagan. He knew this was something special, calling it a moment to celebrate an epic journey. And that's exactly what it was. Humanity's little robotic explorer, Voyager 2, was finally nearing its last stop in our solar system, the mysterious, deep blue world of Neptune.
So how did this incredible voyage even happen? I mean, what made it possible? Well, it all came down to a little bit of cosmic luck, a really, really rare alignment of the outer planets, Jupiter, Saturn, Uranus, and Neptune, something that only happens once every 175 years, a true once-in-a-lifetime shot.
The whole mission, the entire Grand Tour, was built around this absolutely brilliant idea called a gravity assist. The best way to think about it? It's like a cosmic slingshot. You aim the spacecraft just right, letting it swing by a massive planet, and its gravity grabs you, whips you around, and just flings you towards your next destination. It's an incredible way to save tons of fuel and shave years off the travel time.
And here you can see that path in action. It's amazing, right? Voyager 2 didn't just point itself at Neptune and go. No way. It had to thread this perfect needle through the outer solar system. It hopped from Jupiter to Saturn, then all the way out to Uranus, getting a speed boost at every single stop. A journey that took over a decade and crossed billions of miles of empty space.
Okay, but to pull off a trip of this scale, you need a pretty special machine, right? So let's meet the star of the show, the incredible robotic explorer that made this whole thing possible.
Just look at this thing. For a piece of 1970s engineering, Voyager is an absolute marvel. Think about it. Way out in the dark, cold frontiers of space, solar panels are totally useless. There's just not enough sunlight. So how do you power it? With nuclear batteries, essentially. They use the slow, steady heat from decaying plutonium to generate electricity, enough to keep it running for decades.
But the journey was anything but smooth. In fact, Voyager 2 was nicknamed the Troublesome Twin. And for good reason. Really early in its mission, its main radio receiver just died. Total failure. For a scary moment, they thought the whole mission was over, that the spacecraft was lost forever. But the engineers back on Earth, they were brilliant. They figured out a way to talk to the much weaker, flawed backup receiver. It was a workaround they had to use for the entire 12-year journey. Just incredible problem solving.
So, after 2 long, quiet years cruising through space, in 1979, Voyager finally arrived at its first stop. And what a stop it was! The king of the planets itself, Jupiter.
Now, you have to remember, before Voyager got there, our view of Jupiter's system was, well, it was fuzzy, distant. Yeah, we knew about its 4 big moons, but they were really just dots of light in a telescope. Voyager was about to turn those dots into entire worlds. And what it found, I mean, it was just stunning. It blew everyone's minds. Scientists were expecting to see dead, crater-covered rocks. Instead, on the moon Io, Voyager found active volcanoes, erupting, spewing sulfur hundreds of kilometers into space. It turned out to be the most geologically active place in the entire solar system. Nobody saw that coming. It was a total shock.
And it wasn't just Io. In that one single flyby, Voyager completely rewrote the textbooks on Jupiter. It found a faint, dusty ring system nobody even knew was there. It spotted 3 new moons. It showed us that the Great Red Spot wasn't just a feature, it was a gigantic, swirling storm bigger than our entire planet. And maybe, just maybe the most exciting thing of all, it gave us our very first clues that there might be a vast liquid water ocean hiding under the icy crust of another moon, Europa.
So, after completely changing our view of Jupiter, Voyager did its thing. It used the giant planet's gravity as a slingshot, flinging itself on to the next destination, the absolute jewel of our solar system, Saturn.
You know, when Voyager got to Saturn, the biggest surprises were hiding in plain sight, in its famous rings. What we saw from Earth looked like a few smooth, wide bands, But up close, oh, it was a whole different story. Voyager showed us that the rings are actually this breathtakingly complex system of thousands, maybe even tens of thousands, of tiny individual ringlets, all packed together like the grooves on some kind of cosmic vinyl record.
And Saturn's moons? Well, they held their own secrets. It was like a tale of two different surfaces. Most of them were what you'd expect, dark, ancient, and just covered in craters. But then there was this one little moon, Enceladus. It was totally different. It was bright white, its surface was smooth, and it had almost no craters at all. All of that pointed to it being geologically young, maybe even active right now, a huge mystery for such a tiny, frozen world.
So when you put all these pieces together, the thousands of ringlets, these strange active little moons, it led scientists to a really startling new idea. What if planetary rings aren't these ancient, permanent things that have been around since the solar system was born? What if they're actually young, dynamic, constantly being created from the shattered debris of small moons that get too close? It totally changed how we think about rings.
All right, so after Saturn, Voyager 2 just kept going, sailing on for 5 more long years through the darkness. It made the first ever visit to the strange ice giant Uranus. And then, after completely revolutionizing our understanding of 3 planets, the little spacecraft pushed on, getting closer and closer to its final destination.
I mean, this timeline really puts it all into perspective, doesn't it? It launched way back in 1977. It took 2 years just to get to Jupiter, another 2 to get to Saturn, and then that long, quiet 5-year cruise out to Uranus. Finally, after 12 years and billions of miles traveling through the cold and dark, Neptune was finally in sight.
And that brings us right back where we started, to the summer of 1989. The whole world was holding its breath, waiting for our very first close-up look at this mysterious, deep blue planet and its really strange-looking moon, Triton. What were we about to find out? What secrets were they hiding?
Because after this final encounter, Voyager's mission to the planets would be over. But its journey was just getting started. It was now set on a path to wander the vast, dark space between the stars for, well, maybe a billion years, a silent ambassador from Earth, carrying our story out into the cosmos.
And Carl Sagan, he had one last, beautiful idea. He begged NASA to turn Voyager's cameras around just one more time, to take a final look back and capture a sort of family portrait of the solar system. The picture they took showed our home, Earth, as nothing more than a tiny, pale blue dot, a single pixel suspended in a sunbeam. It was a picture, Sagan said, that could change our whole perspective on who we are. So, what do you think? In the end, Voyager's grand tour didn't just show us other worlds. It showed us our own world in a way we had never, ever seen it before.